Welcome to the Inspiring Tech Leaders podcast with me, Dave Roberts. In this episode, I catch up with Grant Wiseman, who is based in Winnipeg in Canada. We discuss the advances in satellite imagery and remote sensing, and how this is enabling us to help a wide range of industries with unparalleled insights into changes on the Earth's surface. Many thanks again to Stantec for allowing me to share this insightful podcast with the Inspiring Tech Leaders audience. I hope you enjoy this episode.
Welcome to the Stantec.io podcast, where we speak to our scientists, designers, engineers, and architects who are working with our digital practice teams to develop creative, technology-forward approaches that accelerate and improve our ability to solve the most difficult challenges facing our clients, communities, and industries. I'm Dave Roberts, and on today's episode we feature Grant Wiseman, who will talk to us about some of the applications within the Stantec.io GlobeWatch platform. Grant has more than 20 years of experience as a subject matter expert and thought leader for remote sensing at Stantec and is based out of our Winnipeg office in Canada. Grant has a Master of Science degree in Environmental Earth and Resources and has authored numerous publications within his field of GIS monitoring, LiDAR, and optical and radar imagery systems. Welcome to the podcast, Grant.
Hi, Dave. Thanks for having me.
So let's start off by learning a little bit more about you. How long have you been with Stantec, and what's been your technology journey to date?
I've been with Stantec coming up on 9 years now. I started off as a remote sensing analyst in the Winnipeg Business Center. In the technology of remote sensing, it is so useful in so many different disciplines and sectors that it really grew from that business center really across the company. Because of that, I moved into Stantec's innovation office in the digital technology and innovation office, where I am driving innovation and research in remote sensing and driving business development on a global scale on all 6 continents that Stantec does business in.
So Grant, when did you first get involved with GlobeWatch, and how long did it take to develop?
Yeah, good question, Dave. So at Stantec, there really wasn't much remote sensing technology being used when I was first hired. I was primarily working in MyBC, and that quickly spread to Western Canada and then kind of spread to North America. And I think there was a certified effort to bring remote sensing to the forefront in our GIS and environmental services teams. There was a venture fund investment for remote sensing technology, and that spurred the Remote Sensing Center of Excellence. From there, with the marketing team, we grew that into GlobeWatch, where now we have multiple remote sensing analysts scattered across the globe, working on all sorts of projects in environmental services, to energy and resources, to buildings, to infrastructure. It's really applicable to any of the work that Stantec does on a daily basis.
So Grant, can you tell me about some of the technologies we're using to support GIS monitoring and perhaps some examples of how they're game changers for us?
Sure. We're using something called micro-satellite constellations. In years past, space agencies would have one satellite that would collect information of the Earth's surface. Once every 2 weeks, it would take 2 weeks for that satellite to provide global coverage. Whereas nowadays, these microsatellite constellations, they're much, much smaller satellites, so they're inexpensive to build and inexpensive to launch. So companies are launching them literally by the hundreds. And working as a team, they are able to acquire satellite imagery of the entire planet on a daily basis. This allows us to monitor our clients' assets daily, sometimes multiple times in a single day. Using this technology, we're able to shift from where things are happening, but to when things are happening.
Wow, I can't believe how many satellites actually being launched on a daily basis. That's amazing. So what about our GlobeWatch products? Where are they being used?
Sure. Our PipeWatch service is geared for the oil and gas industry. There, we're monitoring hundreds or even thousands of kilometers of pipeline right away looking for leak detection using change detection analysis. We can also look for third-party encroachment and even theft detection using those microsatellites. Our WireWatch service is geared for the transmission and distribution power line sector. There, we're looking for vegetation encroachment, especially after storm events. You might get some vegetation that has fallen and it could strike a power line, and that could lead to a wildfire. There's also our WireWatch service, where we're able to identify and track algae blooms that may interfere with recreational water activities or may even disrupt drinking water supplies.
So can you tell me, how have you been using high-resolution imagery and LiDAR datasets to help deliver successful outcomes for our clients?
Yeah, so we really have access to phenomenal datasets in this day and age. With planes and drones, we can get high-resolution imagery and LiDAR to create really three-dimensional models or digital twin of the landscape. A lot of our clients are interested in capturing carbon, how much carbon is being stored on their properties. So what we do is we use our Extract X mapping technique. It's based off something called object-based image analysis, where we can cluster pixels together based on color and texture and the size and shape of features. So we use that to isolate individual trees and shrubs. From there, we can measure biophysical parameters such as crown diameter and canopy height of each individual plant. From there, we hand that data set over to our carbon experts, and they use allometric models that are species specific to calculate carbon dioxide equivalents. So we can tell our clients with a high degree of accuracy that how much carbon is being stored in their vegetation.
Wow, that's amazing. I also understand you've also been using high-resolution satellite images to monitor extensive pipeline networks. So how has that been achieved?
So there's been a really revolutionary shift in remote sensing and satellite technology. In years past, satellites would cost in the hundreds of millions of dollars. They would be large in size, literally the size of a small car or a truck. But there's been a fundamental shift. Satellites have gotten much, much smaller in size, literally the size of a loaf of bread. So they're inexpensive to build and inexpensive to launch. The older satellites would cover the entire planet once every 2 weeks, whereas these smaller satellites, they work as a constellation. Companies are launching them by the hundreds. So they cover a small portion of the Earth's surface, but working as a team, they cover the entire planet each and every day. That gives us unprecedented amounts of data. So we no longer go from where things are occurring, such as an oil spill, but now we can actually ask when things are occurring. We can compare one day to the next. So we've never had access to such high resolution, high volume data. And that's really the technology that PipeWatch is built off of.
So Grant, how does someone actually access PipeWatch?
Well, we would speak with the client. We would need to know where the pipeline is, the length of the pipeline, how frequently the client would like the pipeline monitored. From there, we can make some informed decisions on what type of satellite imagery to use, what satellite imagery would be most cost effective for their needs. We can monitor for pipeline leaks. We can monitor for third-party encroachment. It has several advantages over traditional aerial coverage where companies would fly planes and a pilot would simply look down at the ground to identify leaks or third-party encroachment. With PipeWatch, we're using near-infrared technology. It's highly sensitive to vegetation health. So if there's any sort of small leak or any sort of encroachment on that pipeline right away, that'll get detected easily using that near-infrared technology. It's invisible to the human eye, so we really can't see what's going on to that vegetation. We are using change detection analysis, so we're constantly comparing one date to the next so we can quantitatively measure how things are changing over time. Several advantages, obviously, over a pilot in the sky. They can't see that vegetation change, and they don't have anything to compare what they're seeing from one date to the next. The nice thing about PipeWatch is it provides a quantitative permanent record of companies' assets.
Oh, fantastic. So what other benefits does satellite imagery help to provide us with?
We have a really wide range of services that we offer using satellite, plane, and drone imagery. Another one that I'd like to talk about is WireWatch. It can use any type of imagery to monitor for transmission and distribution power lines. There's hundreds of thousands of linear kilometers that these owners and operators must monitor. The eye in the sky can actually capture the entire network in a single snapshot. So it gives them unprecedented access to what is going on their network distribution in a single picture.
And what other technology approaches are we using to help reduce client project costs and any other associated benefits we've got from these solutions too?
Sure. So we have our AirWatch service. We're looking for greenhouse gases and particulate matter for health and safety concerns to the public. Our WaterWatch service uses satellite imagery to look for water quality parameters such as total suspended solids and looking for contamination to water bodies. Remote sensing offers tremendous value by gathering detailed information of our clients' assets, and it's really reducing the need to have field crews out collecting ground data. This is especially true in hard-to-reach, isolated regions of the world. Thereby, by limiting field teams, we overtly reduce health and safety risk that has inherent problems with it.
And if we were to look at some of our historical data, are we able to better predict and perhaps even prevent such instances as surface deformation issues occurring? Is that possible?
Absolutely. That is our ground watch service where we're using freely available radar data. The European Space Agency has a 6-year global archive of INSAR data where we can actually take that data, monitor it for those 6 years, and with millimeter accuracy and precision, we can tell you how much of that ground surface is moving on the vertical axis. Is it uplifting? Is it subsiding? We've done numerous projects with dams and levee companies, pipeline companies looking for geohazard movement that would threaten their assets, infrastructure for roads and railways, and even things like shoreline erosion. Where is the shoreline eroding, and where is that same shoreline gaining ground from deposition from wind and water?
So what technologies are you mostly excited about, and how do you think they're going to impact the GlobeWatch platform?
We have unprecedented access to imagery, as I already mentioned, with PipeWatch. We're getting daily imagery of the Earth's surface now, and that's going to only increase. So I'm really excited about all these different applications that we can come up with using this satellite data. There are a number of new missions being launched in 2023 that I'm excited about. One is by NASA called NISAR, and it's improving upon the European Space Agency's INSAR product called Sentinel-1. We're going from free 20-meter data down to free 3-meter data. So I think that'll really improve our ground watch product, getting that increased resolution that'll give our clients an even better sense of as to what's going on with surface deformation issues. Another one is PACE. This is a hyperspectral scanner. So traditional RGB and near-infrared imagery is only 4 bands. Those bands are really quite wide in the electromagnetic spectrum. But with hyperspectral sensing, the bands are really, really narrow. only a couple of nanometers, but there's hundreds of them. So we can get extremely detailed spectral reflectance values from hyperspectral sensors. And this data, again, is going to be free to the public at 5-meter resolution. We've never had access to hyperspectral imaging as we will coming in 2023. And Stantec is well positioned to take advantage of that hyperspectral imagery to serve our clients that much better.
So if I wanted to learn more about Stantec.io GlobeWatch platform, what should I do next?
You can see much more of the GlobeWatch platform on our online page at Stantec.io. You can also check out our GlobeWatch video that is posted there to give more information on each of the individual services that we provide. And as always, you can contact me directly at grant.wiseman@stantec.com.
Well, it's been a real pleasure talking with you today about the vast array of digital solutions that we offer across the GlobeWatch platform, and just wanted to thank you once again for being part of the Stantec.io podcast, Grant.
Very good, Dave. Thanks for the opportunity.
Thank you for listening to the Stantec.io podcast. If you've enjoyed listening, please tune in to future episodes where we'll continue to explore how digital solutions are shaping our world. In the meantime, you can also visit our website at www.stantec.io for further information.
Please remember to subscribe to the podcast and stay tuned for more inspiring tech leaders.